Hello, and welcome to Section 5.1 on the area between curves. In this section, we are interested in calculating the unsigned area, the total area, between two curves. However, we must do this using integrals, which represent the signed area, the net area, between curves. Recall that the total area is calculated by integrating using the absolute value. The focus of this section is on calculating the area of two types of simple regions, x regions and y regions. An x region is a region which is defined by x-valued functions. That is, a region R with top boundary y equal to f of x, bottom boundary y equal to g of x, left boundary x equal to a, and right boundary x equal to b. This x region has top boundary f of x equal to negative x squared plus 4, bottom boundary g of x equal to negative x minus 3, left boundary x equal to negative 2, and right boundary x equal to 2. The area of the region is the integral from a to b of the absolute value of f of x minus g of x dx. We can drop the absolute values because the top boundary minus the bottom boundary is positive. That's because f of x is greater than g of x. Solving for 0 shows that f of x minus g of x is positive. The area of this specific x region is the integral from negative 2 to 2 of negative x squared plus 4 minus negative x minus 3 dx. Simplifying, this is the integral from negative 2 to 2 of negative x squared plus x plus 7 dx. Computing the antiderivative, we are left with evaluating negative 1/3 x cubed plus 1/2 x squared plus 7x from negative 2 to 2. Resulting in an area of 68 over 3 units squared. A y region is a region which is defined by y-valued functions. That is, a region R with right boundary x equal to f of y, left boundary x equal to g of y, bottom boundary y equal to a, and top boundary y equal to b. This y region has right boundary f of y equal to y squared, and left boundary g of y equal to 2y squared minus 4. The functions intersect when f of y equals g of y. That is, when 2y squared minus 4 equals y squared, which is equivalent to solving when y squared minus 4 equals 0, or y plus 2 times y minus 2 equals 0, which coincides with the values of the bottom boundary of y equal to negative 2 and the top boundary of y equal to 2. A note on graphing y-valued functions. To graph f of y equals y squared, graph the equation y equal to x squared, then reflect the image over the line y equal to x. To graph g of y equal to 2y squared minus 4, graph the equation y equal to 2x squared minus 4, then reflect the image over the line y equal to x. The total area of a y region is calculated as with x regions, except we integrate with respect to y, as it is the independent variable. The right boundary minus the left boundary is positive, as the right half of the plane is positive and the left half of the plane is negative, just like the top is positive and the bottom is negative. Remember, top minus bottom, right minus left. These are always positive. You've seen the basics, now work towards mastery through practice and study.